We're now going to go into the short research presentations of about 10 minutes each. So I'm going to invite those who see themselves listed on the schedule to be prepared to come up quickly. And then we're going to go through that, and then we'll finish off with a paper on safety. So our first presentation today is on brain creatine metabolism modulated by hydrogen-enriched water by Dragana Zanini. Please come up.
My name is Dragana Zanini, and I'm coming from University of Novi Sad from Serbia, and I'm a psychologist that is working in Applied Bioenergetics Lab that is leading a professor that is under leadership of Professor Ostojic. So the creatine is considered as a relatively stable neurometabolite that steadily declines over the course of life. So it also plays a crucial role in aging by supporting cognitive health and functions, and also promoting neuroprotection. Therefore, optimizing creatine levels in the brain is of great interest, especially in old people. But as Professor Kendall said, there are no evidence that creatine supplementation could benefit creatine metabolism in the brain of old people. So the rationale behind this research was to examine whether some kind of different supplement, non-conventional creatine supplement, could optimize creatine level in the brains of older people. Therefore, for this purpose, we used hydrogen-rich water, which is hydrogen-based product. Molecular hydrogen is proved is well known for its antioxidative properties. And it's also proven to be beneficial for different processes like inflammation, apoptosis, and even in some extent to gene modulation. So we want to examine if hydrogen-rich water could optimize brain creatine metabolism in the older adults. This is actually the part of the larger randomized control pilot study that included 40 people over 70 years of age. For this subsample, we used 8 participants that voluntarily underwent magnetic resonance spectroscopy with mean age of 75 years, and that was gender balanced. So about protocol, the bout group was randomly allocated to intervention, hydrogen-rich group, hydrogen-rich water group, that or control, the group that was drinking control drink. They were drinking the control or HRV drink for 6 months. In the total amount of 500 milliliters per day, 2,050 in the morning and 2,050 at the evening. So this is basically the tablet that is dissolved in a glass of tap water. This is we extracted molecular hydrogen from the interaction of magnesium with water. And both drinks, control and HRV, was similar in appearance, texture, and sensory characteristics, and normalized for total amount of magnesium. So we assessed the 13 positions in the brain. On the left side, it's a single voxel spectroscopy, and it's positioned on the left thalamus. And the second is multivoxel spectroscopy, which was positioned above corpus callosum in the centrum semiovale, and it includes in post-processing. This large multivoxel was divided into 12 locations. As you can see, the lateral white boxes are white matter, and medial black boxes are are gray matter. So it includes frontal white and gray matter, pre-central white matter, paracentral, that is the middle paracentral gray matter, and the posterior parts are the parietal white matter and parietal mesial gray matter. So we performed magnetic resonance spectroscopy on the 1.5 Tesla scanner, and it was done with non-suppressed 2D chemical shift imaging, and single voxel spectroscopy was applied to obtain water. We used water as internal reference for the absolute quantification of creatine. And creatine is further calculated using water-suppressed CSI, and for the single voxel spectroscopy was assessed through the PRESS technique. So the results, as you can see from this table, after 6 months of intervention, the results show that there were 2.5 significant results. I say half because on that first position of frontal gray matter, on the right side, there is a trend towards significant changes because the p-value is 0.08. So you can see on that voxel that HRV group had a higher concentration of creatine than the placebo group. The same trend is observed, the same significant differences is observed on the voxel of parietal white matter on the right side. The HRV group had a higher concentration of creatine comparing to placebo group, and in contrast, placebo group had higher concentration of creatine after 6 months of intervention on the voxel of parietal mesial gray matter on the left side. This is just that you can see the position, and the position is opposite than in reality as in mirror. So if an old age is associated with decreased level of creatine, then beneficial effects of supplements should elevate, as the hypothesis is that we should expect that beneficial effects elevate creatine levels. So we've shown that in 2 of 3 are significantly changed voxels. But we should bear in mind that increased creatine levels could also be a mark of cognitive decline and subsequently mild cognitive impairment in some cases, as previous research has shown. So the increased creatine levels could be also some kind of compensation for naturally occurring cognitive processing efficacy, a reduction in cognitive processing efficacy, which is common for old people. So to conclude, in addition to conventional creatine-enhancing supplements, hydrogen-based supplements could also benefit creatine levels and may modulate age-related and brain region-specific creatine dynamics in the brain. As Professor Tarnopolsky said, maybe the future perspective of creatine research is to combine more than one supplements, because they can tackle different roots and underlying mechanisms, and maybe to have creatinity in the research. Okay, this is hypothesis that should elaborate in the further research, and to validate these findings also. Thank you for your attention.
Thank you very much. Very interesting presentation. Our next presentation is going to be from Diego Bonilla from CES University and DBSS. And he's going to talk about creatine supplementation on effects creatine supplementation on body composition and sport performance in team athletes. Do you have a different one? Okay, he's got two, so he's going to switch them around. Properties and sensory adaptability of creatine-fortified foods. So we're going to talk about KREAFOOD and adding functional aspects to food. Thank you.
Mateo, la otra is the other one. Okay, thank you, Doc. And yes, as is planned, we were to explain some of the results that we have found regarding the creatine enrichment in certain foods. This is part of an innovation project called KREAFOOD. And also I will explain a little bit about the CREAS system. So sorry if maybe I go a little bit in 1.5 or almost 2x, just to reach to present all of this, because I guess that you will find interesting. So my disclosures, you already know about them. So as the first part, we'll be focusing on the KREAFOOD. I hope to spend here maybe 70% of the talk, and the second one on the CREAS system. So this project was born almost by 2021, almost 2022, the beginning, in a collaboration between the research division of DBSS and the CES Neutral laboratory in the Universidad CES. We started doing this aware that there are some core problems like the underutilization of creatine for health and nutrition sustainability. There are some causes about this, like fear and extreme caution that exist, some lacking about public awareness, and several others that at the end just results in, as we know, premature aging, some higher rates of depression, poor quality of life in the population. This was based on the master food systems of the European Union. And as Dr. Ostojic has highlighted previously, there is a need to start including creatine and enrich some foods. Actually, taking advantage of the generally recognized as safe act that it's for the ALSCHEM creatine. So, and considering the recent position of the European Union as well about the safety of including creatine in food. So that's why we start just measuring and creating some products that we already made stable and has just doing some sensorial analysis that I will show today. So we already did mochaccino, cappuccino, kumis, cereal bars, pancakes, and ice creams. This has been tough, and it's not in the, maybe in a almost finished product. We continue working on this hard. But the others, and hopefully you will try this one, the pancakes and the mochaccino in just minutes. We are already done with those. So we are going to show you that we compare some with the KREAFOOD and some other commercial available products and creatine monohydrate. All of those, regarding the pancakes, they are containing 10% of creatine for a serving of 35 grams of the powder. It is dissolved in 60 milliliters of milk and preheat, and then you just go with until the golden brown of the current pancake. We analyzed several stuff regarding some of the sensorial parts of the products. These were blinded for your knowledge, and this in this case, the P972, this was the KREAFOOD. And we found not only a significant difference here, but also with several other testing that allowed us to say that just analyzing quantitative data, it appears more favorable about the sensorial thing. But then we just create a panel of 15 evaluators, again, randomly assigned and using just blinded samples. And the preference for the KREAFOOD product was higher. Actually, we can see it here. This was complemented with a texture profile analysis that is not shown. And the same with the mochaccino. We have a similar testing. We end up with some features, not all, but maybe the sweet, the cream profile, and the good chocolate aroma that just also make it something interesting for the KREAFOOD part. In this case, I have to say that it was under the dose preferred by the panel. Again, they preferred one of those were significant in the proportion of the creatine-based food. And that's a very good thing that we have already just advanced. And now the others, even the ice cream, I can say that maybe not showing some quantitative data here, but that it's already done in a very good way. And so the next step is that we are already contacting some of these industries that can help us with the production and start commercializing. That's why we have been in touch too close with all the Alzchem group as well, just to continue with that part of the commercialization. So, and finally, just to talk about the CREAS system, maybe you heard about this yesterday. So we are working on a hub of information that you can find in creas.pro, creas.pro, just in case. So when you go here, you will find certain analysis that has been just embedded in using open science, using AI tools, and some other advanced statistical analysis, like enrichment and gene annotation and some other that analyze omics data. And maybe if you go to the site, you will find, for example, for bioinformatics, it is divided in several parts. One is the metabolomics. Once you go there, you will find even creatine spectra, the patterns that exist regarding the mass spec, liquid chromatography, and gas chromatography as well, and also the NRM spectra. Those are annotated ones that are the ones that we use to compare in chemical analysis. Also regarding the enzymes, certain cross-referencing regarding some other databases, and even RNA and protein tissue expression. This has been also with the full panel of prioritized genes that we use for creatine-related metabolism. And as you can find in the system, you will also see certain figures that can show you the RNA expression in each tissue and the protein expression levels. So we hope that this helps also with not only with the part of education, but also annotation and some other functions that the people and researchers can extract. You can find also enrichment analysis like these ones. So in here, there are certain of those genes and certain gene ontology terms for biological processes, molecular functions, and some others. And certain diseases that can be affected, for example, decreases in body mass or abnormal spatial learning, and some others that are currently linked to the low creatine levels. Also, you can go from some clicks that exist there in the website to other enrichment tools, like, for example, for those 9 genes, what are the transcription factors that regulate their expression? What are the pathways that are associated with those genes? And also regarding even mouse or some other molecular signature databases, for example, as I explained in the last lecture, or even ontologies for cellular component, molecular function. So it is quite interesting, all the things that we can do nowadays with open data. And also just you will find bibliometric plots that can help you to have an idea of who is working on creatine, who is maybe the most influenced, or those countries that collaborate also, and even some enrichment tools for snowballing when we are doing a review. So you just take here, go, and we can from one node extract and extend a network that can just connect with several papers that sometimes we just lack to find those in the databases, no? So sometimes with the algorithm, we can miss some of this information. Finally, but not least, the scientometric part. So this is the Google Trends, as I was showing. This is automatically updated. So even now you can see what is the data, and we have done very good job because Google Trend is marking that we have the highest spike about the creatine in history now. This is from this last day, so I just pick up here the January 25, but you can see that it continues counting. And some history as well. I'm missing just the previous conferences. I'm sorry about that. Just Dr. Kreider told me about the 2002 conference. So it's missing to add here, but you will find some of those. What are the future directions of all of this? That we are now doing some contamination also analysis. We have advanced with certain DSC that help us with the impurities of the samples. Also, Fourier transform infrared spectra to analyzing unknown or maybe undesirable compounds in dietary supplements. This is something that is taking place right now in our labs and with other techniques that help us to maybe recognize differences, physicochemically speaking, about different samples of creatine that are commercially available. This will help us as well to see if we have impurities or, as a third-party organization, we want to do that step in the near future. So that's one we would like to introduce this more. So these are just plots of the DSC and the infrared spectrum for certain products. I want to say thank you, obviously, because this is always a team effort. As part of both institutions, there are several people working in the University of CES and our research division, especially Dr. Julian Quintero, who is also working too hard on this. And from the CREAS system, we have been working with certain members of our divisions. And I want to say thank you to Dr. Avi Majahan as well. I was educated and former student of his lab several years ago, in 2015, like 10 years ago. So in the New York and the Avi Mahajan lab. So several tools that are now open source and that they are available for all of us has been possible because of their hard work. So just wanted to recognize that. And thank you very much.
Thank you, Diego. For those who are watching online, you may have heard dishes and food. They handed out pancakes with KREAFOOD in it, which tastes really good, and even a mocha coffee, which was very good. So thank you. So proof of concept. Okay, our next presentation is from Bogdan Andjelic, is that correct? And he's going to present a paper on single bout of high-intensity endurance exercise session affects salivary markers of creatine in healthy young men. Maybe a way to assess acute responses, so very interesting.
Okay. So I believe your mouth is full of saliva right now, but this was not the case when we did our study. So in a single bout of high-intensity exercise, we try to see how creatine metabolites actually were affected pre and post exercise. It was endurance exercise, so a little bit of a follow-up with Professor Forbes' talk before. So let's get back to the disclosures. No disclosures, still young, I guess. So the quick background, I'm not really going to go back to what we've already heard a lot of times over the past 4 days. But just quickly, obviously it's been around for, well, soon enough, it's going to be like 2 centuries, right, since its discovery. But just briefly, the endogenous and then the exogenous sources of creatine depicted here, and the creatine in the middle as obviously a very now famous molecule in the field of biomedical research. The quick background also is, obviously we know that as soon as the exercise levels kind of escalate, creatine, phosphocreatine obviously are among the first to get depleted. And our previous research has shown that a single session of exhaustive exercise decreased certain biomarkers of creatine metabolism. So this is what was initially the whole idea, and then we build up a kind of on this one. But the latest study we've done in 2024 was actually something different. Although we used a slightly different protocol of endurance exercise, we found that actually circulating creatine metabolites were not affected after the exhaustive running to exhaustion protocol on treadmill. So since we kind of realized that something's happening, we looked at the data and we haven't really found anything that's related to saliva so far. And then given the vast amount of evidence on creatine, obviously all the way from semen to plasma to obviously different kind of tissues, and creatine's been around for years, and we know that it's also not only in the muscles. So we try to see what's happening in the oral cavity and how really saliva responds to exercise, and then we obviously went with the main objectives and the hypothesis where we try to see, could saliva replace blood biomarkers? Probably not, but we want to see if it's possible, right? Is it reliable? And then also how exercise affects creatine metabolism compared to blood. So straight to our subjects, we can see the inclusion and exclusion criteria. I'm not going to go like, you can obviously see them pretty clear. So obviously young collegiate athletes in a normal BMI category between the age range, as you can see here, all of them were non-vegetarian, so consuming, I guess, a lot of red meat, possibly even chicken, right? We haven't really controlled for these kind of factors. So yeah, we can see some issues with my presentation, but obviously they were all exercising at least 5 hours a week for the past 3 years. All of them had no any of the chronic or acute medical conditions and were not using any supplements before. So the lab visit actually was between 7 and 10 a.m. All of them pretty much completed a familiarization session before. We know these guys, most of them. And then, as you can see, the order of actions, these guys were arrested for 24 hours before, had no any coffee or food intake before coming to the lab. And then this is obviously not a kiss, but we gave them distilled water just to make sure that it's kind of like clean, right, before taking the samples from the oral cavity. So the fasting venous blood was drawn from the antecubital vein, and then also a specimen of unstimulated whole saliva beneath the tongue was taken before and after the treadmill protocol. So we used a 3-minute warm-up at 5 kilometers per hour, and then every minute, 1.5 kilometers per hour was added as an additional stimulus to the, until they reached the exhaustion, right? So we gave them no option for a cool down, so we want to take them as soon as they get off the treadmill. And then the sample analysis was quickly analyzed for the guanidinoacetic acid, creatine and creatinine using a liquid chromatography. We have details here if you're really interested into the biochemistry. Results, quickly gonna go over the main findings here. This is unpublished data, so we can't really give you everything now. So 15 subjects, right? You can see the BMI and the age there. Obviously, we haven't found really a correlation between creatine and creatinine, between saliva and blood. But what was interesting is that a significant increase in creatine was observed pre and post exercise, but not in the serum. So you can see the table here. However, our guanidinoacetic acid levels remain below the limit of detection. Obviously, we can switch the methods, possibly using a gas chromatography maybe, but this is what we found so far. You can see individual differences in panel A for salivary creatine and creatinine, and obviously 100% change. Like all of the subjects changed pre and post, whereas for the creatinine, only 73%. I mean, only. Not all of them, obviously. And then for the panel B, we can see the serum creatine and creatinine obviously haven't really significantly changed. What was kind of a discovery for us at this point. So for the perspectives, we can see that there's obviously a really good potential in saliva. However, lots of different research needs to be done in this medium because it's really not so far explored in the area of creatine metabolism, at least. Most of the studies trying to see if there's anything related to cortisol most of the time. So also some questions really kind of open up after this study. What's happening with an oral cavity by itself is the creatine that's actually found in the oral cavity going back to circulation, and what's this data actually meaning? At this point, we don't know, but we found that actually some salivary creatine metabolites are actually responsive to running to exhaustion protocol in this case. To main limitations, obviously, are the type of exercise. We only use running, no weight resistance. We haven't checked for the food intake. We didn't check for dehydration. We checked the physically active population. Only 2 sampling pre or post. We haven't really checked for how long this change should be detected. And then also the methodology issues such as gas chromatography could be probably utilized. As the conclusion, salivary but not serum biomarkers of creatine and creatinine significantly increased after exhaustive exercise in young healthy subjects. And these probably should not be used interchangeably. As you can see, these two bodily fluids are different in terms of creatine metabolism. And then lastly, this is obviously an unexplored area, and we really would hope to get some additional work done on this matter. Thank you very much for your attention.
Thank you, Bogdan. All right, we're going to bring back up Diego Bonilla, and he's going to talk about team sports in supplementation. Come on up, Diego.
Okay. Hello again. Now to show some clinical data just about the dietary supplementation with creatine monohydrate. So we evaluated in two studies. We have some elite athlete sports, and it's not. And we evaluate in the first study that I will show some handball and softball players, both sex, and elite athletes from Colombian teams. So what we did was a triple arm, triple blind, placebo-controlled clinical trial. So, and thank you, Matteo. So is this one? And we compare the effects against creatine hydrochloride, HCl. We evaluated several variables of strength and body composition in these athletes that I was mentioning before. So, and the second one will be another clinical trial that we did in soccer players, again, semi-professional those, and young athletes. So for the first one, we use a low-dose creatine supplementation protocol, just trying to test these claims that low dosages of creatine hydrochloride are better than creatine monohydrate. So what we did was an 8-week study. They were randomized, assigned to these groups, and we used placebo maltodextrin. They use 5 grams per day of the creatine. And we use dynamometer for the shoulder, internal and external rotation. Also the load versus velocity profile, and also some power for the lower limbs, and DEXA as body composition. Okay, I will pass by this. For body composition, I have to say that we also corrected for the fat-free adipose tissue, as we have been doing in certain research recently, and after the recommendations by Dr. Abe and Loenek regarding the effects after repeated measures in sports nutrition. So at the end, after allocations, we started with 68 subjects, but we'd end up with 11 for the creatine group, 10 for the HCl, and 10 for the placebo. This was a probabilistic sample that we calculated. We use with the data robust statistics. As you know, low samples require different treatment for the data. So for the group of the creatine monohydrate, this was the distribution between sexes. We find after 8 weeks, significant differences in the pair comparison for also the FFM index. As you know, this is a surrogate marker of also for body composition, and especially in athletes, not only using the FFM data, the raw, but just this is adjusted for the stature the square. And also for the HCl, there were some significant differences between also some of the plyometrics and some others in the body composition. For the placebo, there were no effects, so both creatines worked. But when we ran the ANCOVA using the pre-values as the covariate, we didn't find any significant difference or interactions between the groups. There were certainly higher size effects in the, effect sizes, in the creatine monohydrate group. So that it's something that require maybe further exploration with a higher sample, or maybe a different time in the dietary supplementation protocol. So what our conclusion is that there are no statistically significant differences between these types of creatine, and we can say that creatine hydrochloride is not superior to creatine monohydrate, and actually there are some higher or larger side effect sizes, sorry, with the creatine monohydrate group that expects to be explored. So on the second one was a 10-week dietary supplementation protocol. In here we use a medical team of the Cortuluá. This is it was in the first league in Colombia and in the soccer league previously. Now it is in the second one, but they are still quite using several also performance metrics like the catapult system and some others, and this is what I want to show. So we use the semi-professional young players of this team, the under 17 until the 1C, the first league is the first A, so for you to have a reference. And we started with a sample of 52 soccer players, but we'd end up with this division of the groups after the allocation. So we tested protein plus creatine alone, or placebo. And again, we measure creatine kinase, in this case with the serum after this was measured 2 or 3 days post-training. We standardize it to use this as a marker, when it's increased after exercise. So we pass this window and then we measure it. We use the catapult system and some BIA and anthropometrics to evaluate. Again, robust statistics, and we find that protein plus creatine was significantly difference to the changes in creatine kinase in reduction in this one, in this variable, and also with the Player Law index that it's a sum of the accelerations that the system just give us, and this is divided by the scaling factor just to have an idea of each player load. So for the groups of maltodextrin and the protein alone, there were higher values in comparison with those that included creatine. So again, here we found that the creatine addition, in this case with protein, was a better decision. So again, just confirming maybe what we already know in sports nutrition, but was missing at least for Colombian athletes and in young population. And so we can say that consuming creatine monohydrate and whey protein, whether taken separately or together, can lead to positive changes in reduction in muscle damage, also improving the training load of these athletes in 10 weeks after 10 weeks of supplementation. So thank you so much.
Thank you, Diego. All right, we have 2 more. Our next presentation is also from Bioenergetics Lab, David Nedejkovic. Is that correct? Very good. All right, and he's going to give us an overview of the effects of 8 weeks of creatine supplementation with and without ubiquinol on sperm creatine content. Wow, very good, interesting.
Thank you. Okay. Firstly, I would like to greet everyone and to thank the organizers for the opportunity to present our results. My name is David Nedeljkovic, and today I will be discussing our research on male fertility and creatine supplementation. Male infertility is a multifactorial issue, which is probably the main reason why there is a lack of successful interventions in this field. What's currently known is that low levels of semen creatine are associated with decreased spermatozoid motility, therefore highlighting the importance of creatine homeostasis in the viability of the sperm. Previously conducted animal studies, namely on boars and roosters, showed the potential of exogenous creatine in increasing sperm motility and therefore fertilization ability in these animals. Another pair of promising animal studies highlighted ubiquinol, the reduced form of coenzyme Q10, as a promising nutraceutical for fertility enhancement. Combinations of creatine and ubiquinol have been previously used and have been shown as effective, mostly in conditions involving some kind of cognitive impairment, but their effect, either alone or in combination, on male fertility are unknown. Therefore, we decided to assess the effects of an 8-week supplementation regimen on the biomarkers with creatine monohydrate, both alone and in combination with ubiquinol, on the biomarkers of creatine metabolism in seminal plasma samples, as well as some additional key spermiogram parameters in normospermic and oligospermic men. In our study, we included the male participants aged 18 to 50 with BMI values ranging from normal to overweight. At least a third of our participants were required had to be classified as oligospermic, which was defined as having less than 15 million active swimmers per milliliters of semen. The exclusion criteria were common for this type of research and also included taking any dietary supplementation in the previous 4 weeks. The design of our study was as follows. We included 15 volunteers that were randomly assigned to one of the 3 groups, 2 experimental groups and 1 control group. The experimental group 1 was taking 5 grams of creatine monohydrate daily. The experimental group 2 was taking 5 grams of creatine monohydrate plus 200 milligrams of ubiquinol daily, with the control group taking 5 grams of inulin daily. Here you can also see the distribution of oligospermic participants among these groups. The outcome measures were assessed at baseline and at an 8-week follow-up, with the primary outcome being the change in sperm concentration. Another focus point for us were the biomarkers of creatine metabolism, and we also included some additional spermiogram parameters, as well as TEC as a measurement of antioxidative capacity in our samples. There were no exclusions, nor dropouts, or any reported side effects, and the compliance with the intervention was notably high. Talking about spermiogram parameters, namely the sperm concentration, our intervention led to a non-significant increase in sperm concentration. However, we did observe some kind of trend for improvement, since all of the oligospermic participants in experimental groups showed increased sperm concentrations post-intervention compared to no change or even further decrease in the oligospermic participants of the control groups. Moreover, 60% of normal spermic participants in experimental groups showed improvement compared to only 20% of them in the control group. We did observe some significant changes in spermiogram parameters, for example, the sperm volume for experimental group 2. More interestingly, when assessing the biomarkers of creatine metabolism in seminal plasma, we observed a significant increase in creatine and creatine kinase concentrations in the experimental group 2, that was the experimental group with ubiquinol. For comparison, there were no changes in both of these parameters in the control group throughout the study. During this part of experimental work, my colleague and I developed an innovative method for sample preparation and for analyzing the biomarkers of creatine metabolism, namely these 3, in seminal plasma samples using high-performance liquid chromatography. However, the detection limit of our method was insufficient in detecting any of the guanidinoacetic acid in our samples. Summarizing, we can say that there was some kind of improvement in sperm concentration since all of the oligospermic and 60% of normospermic participants of the experimental groups showed improved concentrations. And that increase was insignificant for this sample size. However, we observed some significant changes. For instance, significant increase in creatine and creatine kinase concentrations in experimental group with ubiquinol, and therefore we hypothesized about the potential effects of ubiquinol in facilitating delivery and utilization of creatine to sperm. Moreover, elevated creatine kinase concentrations could point to advanced sperm maturity and turnover. Our results are discussed in more detail in the article we submitted recently that is currently under review, that I will be happy to share once it is published. I would also like to recognize some limitations of our study, most notably the sample size. The sample size should be extended in future studies, and as well as intervention duration that should be prolonged. Probably a separate ubiquinol-only group should be included so we can distinguish between the effects of each component. Lastly, we did not assess for dietary creatine intake or any of the lifestyle or environmental factors that could make a significant impact on sperm quality. On a final note, we could say that our intervention has a very, very limited efficacy when talking about spermiogram parameters, namely the sperm concentration, but there was some significant changes in the concentrations of creatine and creatine kinase in seminal plasma in experimental group taking both creatine monohydrate and ubiquinol. Therefore, we concluded that there are mixed but measurable indications of enhanced support for high energy demands of spermatozoa. For For further comparison on this topic, we think that future research should assess the creatine metabolism biomarkers both in washed spermatozoa and seminal plasma, and do a more thorough assessment of antioxidative capacity of creatine monohydrate and ubiquinol, both alone and in combination. It was my pleasure presenting these results, and thank you for your kind attention.
Thank you, David. Okay, from male fertility, we're going to talk about efficacy in babies. I don't know who put the organization of the conference together, but it's kind of logical, right? We're welcoming back Dr. Stacey Ellery from the Hudson Institute of Medical Research in Australia to give us the latest on impact on neurology in kids.
Thank you, Rick. So again, my only disclosure is that I do sit on the Creatine for Health Scientific Advisory Board for the ALSCHEM group. So we've heard throughout this Congress that creatine is essential for cerebral energy homeostasis under basal conditions. And what we haven't quite touched on as much, but is important to note, that creatine is likely really important for actually brain maturation and brain development in utero. And this is a lovely figure from a fetal MRS study. So this is human data, where we see an accumulation of creatine in the midbrain of the human fetus as gestation progresses. So where is this creatine coming from? We've shown that the human placenta produces creatine, so that is likely a source of creatine for the fetus. We've also most recently shown that the pregnant uterus also produces creatine. Again, a likely source of creatine for the fetus. So these are two maternal sources of creatine for the developing fetus. Does the developing fetus itself have the capacity to endogenously synthesize creatine? That's a very good question. From our spiny mouse studies, because we don't know from humans, it is unlikely that endogenous synthesis, and this is systemic endogenous synthesis, occurs until around 0.9 of gestation. So this is late in gestation. So that suggests that the fetus doesn't actually have a large potential to produce creatine. Now, Olivier Prasant's group showed some beautiful data earlier in the 2000s looking at the brain specifically, because as we heard yesterday, the brain can endogenously synthesize creatine on its own, probably actually doesn't care what the kidneys and liver are doing. He showed that the synthesizing enzymes are there in the rat embryo, but again, they're not there at a really high level until late in gestation. And we also have heard about how important exogenous creatine, so an exogenous creatine supply, is for the developing baby in the early neonatal period, where we see that there needs to be a large amount of creatine being supplied to the infant because they are unlikely to be able to synthesize enough creatine to meet their demands, given the amount of growing that a newborn infant is still doing. So this begs the question, our preterm babies, this is the window of viability now. Neonatal medicine has come a long way. We can keep babies that don't even get very far past the middle mark of pregnancy alive. But if they are being removed from that maternal source of creatine, can their brains still have this creatine accumulation that we know is incredibly important for their brain development? So we've hypothesized that potentially no. Preterm babies may become creatine deficient in the early postnatal period because they're removed from that maternal source of creatine too early, and that this may jeopardize their normal brain metabolism and development, contributing to the poor neurological outcomes that we know that these babies are particularly susceptible to. So to get at these initial questions, we launched a cohort study called our Understanding Creatine for Neurological Health, or UNICORN Babies Study. Don't underestimate the importance of a good acronym for your study name. I wish I could say that I came up with this, but it was our neonatologist, and it helped tremendously with our recruitment to this study. We had parents in the neonatal intensive care unit wondering why their babies weren't unicorn babies, how could they get their babies to become unicorn babies. So Give some thought to your acronyms, people. So our outcomes were to assess whether preterm infants did become creatine deplete in the early postnatal period. We wanted to establish the levels of creatine being provided to our babies through their diet during those early days and weeks where they were being taken care of in the hospital, and then to try at least to correlate some of the preterm creatine levels with neurological outcomes. So this was our sampling protocol. Given these babies are so tiny and they're in the hospital for varying amounts of times, we were really opportunistic with our sampling, with the aim of getting a blood sample at least every 2 weeks from when the babies were in hospital. But we really collected a blood sample whenever the babies were having a blood draw for any other diagnostic reason. And we collected teeny tiny blood samples onto these blood spots, which allowed us to separate out the cell fraction from the cell-free fraction. So we could get a creatine measure that was devoid of the red blood cells that we know would muck up our creatine measurements. So whenever we got a blood sample, we tried to get a urine sample as well and a nutrition sample within the same 24-hour period, so we could kind of measure in, out, and around. And then also our babies went into the MRI at term-corrected age, and we did a general movements assessment, which is a non-invasive tool that is used for early diagnosis of neurological complications such as cerebral palsy. So it was an opportunistic study. We kind of just kept going until our resources ran out. We did okay. We managed to recruit 67 babies in total, and these are just the numbers of biological samples that we collected. We were a bit underpowered with the number of babies that we actually got into the magnet, but had relatively good numbers of general movements assessments from our cohort. So from those biological samples that we collected, so the blood, the urine, and the nutrition samples, we used our targeted metabolomics techniques to measure creatine, key amino acids involved in creatine synthesis, guanidinoacetate, and creatinine. In the interest of time today, I'll just present some of our early creatine data. So this is our cohort. We split our babies into 4 different subgroups. So we had our term controls, moderate to late preterm, very preterm, and extremely preterm. You can see here based on the weights, these are some teeny tiny babies. Interestingly, our extremely preterm group were kind of the easiest to recruit to because they spend the most time in the neonatal intensive care unit. And so what did we find? Well, we found, looking at the cord bloods, that there was no significant correlation between venous cord blood creatine and the gestation in which the babies were born. And we just saw this when we broke it down into our subgroups as well. This was the average concentration of creatine just below 60 micromolar, which was similar to what we saw in our large pregnancy cohort study as well. This is what happens to the creatine levels as the babies are on the unit. And so this is just all of the data plotted together. We popped this into a repeated measures mixed regression model that can handle different timing and different repeat samples from different babies. And we found that there is a significant fall in blood creatine in the days post-birth whilst the babies were on the unit. And then when we break that down into our groups and we look at how much creatine each of these groups had when they were discharged, so around term-corrected age, we can see that our extremely preterm infants, their creatine concentrations were much lower than our moderate to late preterm infants and much lower than that 60 micromolar that we were measuring in our term healthy-born babies. And then, so just a quick comment on nutrition. Our breast milk samples, nice amount of creatine. When the babies were on formula, also nice amount of creatine. TPN, so total parental nutrition. This is what our smallest babies get. Absolutely no creatine whatsoever. Chock is full of amino acids. We had to dilute these samples down so much to get them through our LCMS protocol. But yeah, these babies are not getting any nutritional creatine. And then finally, just a quick note on breast milk. So obviously this suggests that these babies should go to breast milk really quickly. But our data suggests that the timing of the breast milk is really important. And this mirrors a study that came out from some of the colleagues in the ALSCHEM group earlier this year, where there are changes in breast milk creatine concentrations in the days after birth. So we have our highest breast milk concentrations immediately after birth, and they fall in the first couple of weeks before reaching a plateau. So for these babies that we might be considering donor milk for, the donor milk timing might actually be really important as well. We shouldn't be giving donor milk to really young babies that are coming from mothers who are feeding babies that are 6, 12 months old at home. So the next steps are obviously to do a bit more in-depth analysis and really tie in the matched sample. So we'll look at in, out, and around individually for each of the babies at the time points that we collected samples. And then obviously to assess any relationships of their creatine profile with neurological development. I honestly think we're going to be way underpowered to be able to do this, but we will have a look and see what the data suggests. So obviously the limitations is that this is all observational. We're not looking for a causal link, and we won't identify one even if even if there was something there, we wouldn't be able to hang our hats on it. But given that we're really talking about the relative ease of a nutritional supplement in creatine, even if there are some associations there, and the fact that we are seeing that these babies are going home with much lower creatine levels systemically than what they would have had if they went home as term big healthy babies, our data may warrant doing a randomised control trial soon to see if we can restore the creatine levels when the babies are receiving care in the hospital. So my big thanks to all of our families who took part in the Unicorn Baby study, and also my colleagues over in New Zealand who did the vast majority of the recruitment of these babies in their neonatal intensive care unit. So thank you, everybody.